Today, this lecture we will discuss about the backtracking. So first, we introduce about what is the backtracking. So backtracking is used to solve problem in which sequence of object is chosen from a specified set so that the sequence satisfies some criteria. Now, back, backtracking is a modified depth first search of tree. In backtracking involve only a tree search, and backtracking is a procedure whereby after determining that a node can lead to nothing but dead nodes, we go backtrack to the node's parent and proceed with the search on the next child. So, in the introduction of backtracking, we call a node non-promising if when visiting the node we determine that it can possibly lead to solution, otherwise we call it promising. In summary, a backtracking consists of doing a depth first search of a state space tree first, and second, checking whether its node is promising, and if it is non-promising, backtracking to node's parents. The called burning the state space tree and the subtree consisting of the visited node is called the pruned state space tree. So example of backtracking like that n queens problem. The object is to place queen on the chess board in such a way as no queen can capture another one in a single move. Recall that a queen can move horizontally, vertically, or diagonally an infinite distance. This implies that no two queens can be on the same row, column, or diagonal. We usually want to know how many different placements there are. This is the backtracking example of n-queen problem. Again, be that queen can move horizontally. We know that the queen can move horizontally, vertically, or diagonally in infinite distance in a chess. So this implies that no two queens can be on the same row, column, or diagonal. So we usually want to know using the backtracking approach how many different placements are possible of queen in a chessboard. Suppose n queen problem like that 8 queen problem. So 8 queen problem we use the 8 by 8 matrix chess, and each queen placed in a place like that no queen attack to other. Suppose that this queen is moved to horizontal, moved to vertical and diagonal. No queen is placed in this place. Similarly, this queen moved diagonally, horizontal and vertical. This is the also suitable place of this queen. And in the third row, the queen placed here, it moved this column vertically, horizontally, and diagonally. So no queen are in this place, so this place of proper place. So this is the one solution of 8 queen problem. So several possible solution of 8 queen problem. Now, so we discuss about four queen problem. The smallest problem of n queen equal to 4 because 4 queen only placed in 4 by 4 board, but we have select 3 queen problem. Then it's not possible because 3 by 3 chess board we cannot place 3 queen in the above rule. So we select the 4 by 4 queen problem. Let us take a look the simple problem of placing 4 queen on a 4 by 4 boards. The brute force solution is to place that first queen, then second and third and fourth, so on. So after all are placed, we determine if they are placed legally. There are 16 spots for the first queen and 15 for the second, etc. Leading to 16 into 15 into 14 and 13, that is 43,680 different combinations possible. Obviously, this is not a good way to solve the problem. So first, let us use fact that no two queen can be in the same row and help us. That means we get a place queen in each row. So we can place the first queen into the first row, second into the second, etc. This cuts down on the amount of work. Now there is 4 spots for the first 4 queen, 4 spots for the second, etc. So 4 into 4 into 4 equal to 256 different combinations. However, we can still do better because as we place each queen, we can look at the previous queen we have placed to make sure our new queen is not in the same column or diagonal as previously placed queen, applying the backtracking approach. And second, then we could use the greedy like strategy to select the next valid position for each row. Like for example, if 4 queens problem, we use 4 by 4 chessboard. Now, first queen is placed in first row. It have 4 options: first, second, third, fourth. First, we select in first column. Now, next queen we cannot select in the same column and diagonal, but we can put in the second row, third column. Each queen cannot attack to each other. Now, next queen in third row, we cannot place in first column because already placed queen. We cannot place in the second column because the second row queen attack in diagonally. So third queen cannot place in third column and fourth column. So we cannot find the solution by placing the queen in the first column and first row. Next, we are stuck. Next. So now what do we do? Well, this is very much like solving a math. As you walk through the math, you have to make a series of choices. If one of your choice leads to dead end and you need to back up the last choice you made and take the different route. Change one your earlier selection. Eventually you will find your way out of the maze. So 4 key problem, not find the solution of the placing of first queen in the first column, first row. So we place backtrack and go to the parent. So Q queen, first queen in first row is not placed in first column, then be placed in the second. After placing the first queen in the second column of first row, the next queen Q cannot placed in the second row first column because first queen is attacked diagonally. And this queen also cannot placed in the second column because first queen already placed in the second column. And second queen cannot place in also in third column because first queen is attacked diagonally. So this queen, second queen, is placed in the fourth column, second. So we place the third queen. The third queen is placed in third row in the first column because this is not violate the rule. Now we place the fourth queen in first column in fourth row. So we cannot place in first column because already third queen placed in the first column. Okay. Next, we place the second column. We cannot place because the first queen already placed in the second column. We placed in third column. So third, after placing a third column, it is follow the obey the rules, and all four queen are placed in the chessboard, and each queen cannot attack to each other according to rule. Therefore, this is the solution of the four queen problem. This type of problem is often viewed as a state space tree, a tree of all states that the problem can be. So we start with an empty board, state at the root, and try to work our way down to leaf node. Leaf node are completed boards like that. First queen, chessboard is empty. First queen is placed in the one position, second position, third position, fourth position. So first queen are placed in the first column. Sorry, first queen is placed in the first column and first row. So second queen cannot place first column and second column, but we can place third. If can second queen is placed in the third, then third queen cannot place in first, second, third, fourth. So we backtrack, go to the fourth. The queen cannot place in first. We can place second. We cannot place third. Third queen placing after two, then fourth queen cannot place one, two, three, four, and we cannot find the solution. So we backtrack on the parent node. The queen is placed first row in first column instead of first row in second column. So for the second queen, we have option. We cannot place one, two, three, but we can place second row in fourth column of second queen. Now next, we placed third queen in the first column, and we have next option 1, 2, 3. We cannot place the queen, fourth queen 1 and 2, but we can place 3. So the solution of state three space diagram, queen are placed on the position of the chessboard 2, 4, 1, 3. This is the solution of three space diagram. So the fourth queen is the example of the backtracking approach. Now again, we summarize this three space diagram with the help of diagram chessboard. First Q is the placed in this position. 1. Second position. So we have 1, 2, 3, 4. We cannot place 1, 2, 3, 4, but we placed the position of this. So in the space tree diagram, after placing the 2, first Q in the column of 2, then we cannot place 1, 2, 3 cross, and we place the value of equal to 4. Now, after placing this Q, then third Q place in the third row first column. We can easily placed. So according to this, third is placed in the first, but we have option for fourth Q, first, second, and third. We cannot place in first, cannot place second, we cannot place fourth, so we place in the third position. So we place in the third position. This is the solution of the fourth queen problem. Next, we discuss another example of backtracking approach.